Why your SQL works in dev but fails in production?
Hi, welcome to Technical V. If you're new here, this channel is about how systems behave in production, not how they look in textbooks. Today, I want to talk about something every developer faces at least once. Your SQL query works perfectly in development. Indexes are there, data is small, everything is fast. Then you deploy to production and suddenly the system slows down. No errors, no syntax issues, just lag. And the confusing part is this: nothing looks wrong. That's exactly why this problem is worth understanding.
Most developers assume one simple thing. If SQL is correct and indexes exist, performance should be fine. That assumption feels logical, but it's also where things start going wrong. Because databases don't execute your SQL the way you imagine. They don't follow the order you write. They don't even care about your intent. They care about something else entirely. They care about cost. And once you understand what cost really means, everything else starts to make sense.
Here's the first mental shift you need. SQL is declarative. Execution is procedural. You describe what you want. The database decides how to get it. Before touching a single row, the database builds multiple execution plans. Each plan quietly asks questions like how many rows might be read, how much memory could be used, how expensive will disk access be, and then it picks the plan that looks cheapest, not fastest, cheapest. Once you see that difference, you start to understand why performance surprises happen. This is where the first illusion breaks. An index does not guarantee speed. An index is only useful when few rows are expected, access is predictable, memory assumptions hold. But if the database believes it will touch many rows, random index lookups become expensive. At that point, something counterintuitive happens. A full table scan can be cheaper. Yes, scanning everything can be faster than using an index. And once that feels uncomfortable, we're exactly where we need to be.
And then comes another surprise: composite indexes. Indexes with multiple columns work left to right. If your query skips the first column, the index may as well not exist. The database doesn't partially trust indexes. It either trusts them fully or ignores them completely. And when it ignores them, it's not being stubborn. It's following the same cost logic as before. Now we reach the most important part of this story. Databases don't know your data. They estimate. Those estimates come from statistics. Statistics tell the database things like table size, value distribution, how selective a column is. But here's the catch. Statistics are snapshots. Data is live. In production, traffic patterns change. Rows grow unevenly. New values appear. And when statistics fall behind reality, the database doesn't become unsure. It becomes confidently wrong.
This is where problems start escalating fast. When a query joins tables, the database must decide join order, and this decision is critical. Join a large table too early, and every next operation works on a bigger result. That means more memory usage, larger intermediate results, slower execution. This is why two queries with the same joins can behave very differently in production. The order matters more than it looks.
Once join order is decided, the database still has another choice to make. How should it perform the join? At a high level, it usually chooses between nested loop and hash join. Nested loops use less memory but repeat work again and again. Hash joins are faster, but they consume memory. And in production, memory is not infinite. So the optimizer sometimes chooses a slower join because it believes the faster one won't fit. To you, that looks wrong. To the database, it looks safe. This leads to one of the biggest myths in SQL. Developers add limit and expect speed. But limit controls output size, not execution cost. The database still scans rows, applies filters, sorts data. Only after all that does limit apply. So yes, limit 10 can still scan a million rows, and this surprises people because it feels backwards.
At this point, developers try to take control. They force indexes, they add hints, they lock execution plans. And sometimes it works, until it doesn't. Hints are not commands, they are suggestions. Before executing anything, the optimizer still checks memory pressure, row estimates, system load. If your forced plan looks risky, the database ignores it. Because in production, the database's job is not to obey developers, it's to keep the system alive.
And this explains a very common mystery. Why queries fly in development but fail in production? In dev, small data, clean distribution, plenty of memory. In prod, skewed data, concurrent load, tight memory budgets. Same SQL, completely different reality.
This is where senior engineers think differently. They don't ask, is my SQL correct? They ask, what is the optimizer assuming? What changed in the data? Where does memory go? Why does this plan look cheaper? They debug assumptions, not syntax.
Databases don't fail randomly. They fail logically, using outdated or incorrect assumptions. Indexes don't guarantee speed. Limit doesn't guarantee performance. Hints don't guarantee control. Understanding how the database thinks matters more than knowing syntax. If you want to understand databases the way production understands them, this channel is for you. This is Technical V. We don't teach shortcuts, we teach reality.